Okay, so what we have to do here is factor this thing. So we're going to have x cubed plus 2x squared plus x. And we know right away we can factor out an x from this. And then we'd have x squared plus 2x plus 1. All right, so what two numbers multiply to 1 but add to 2? It would be x plus 1 and x plus 1. So this is actually going to be x times x plus 1 squared in that denominator now. So we can rewrite this thing. And I'm just going to focus on the fraction right now, not so much the integral. We'll come back to the integral. And that's going to be x times x plus 1 squared. Okay, so notice that what we have here is two linear factors. We have one linear factor that is x, and the other linear factor is x plus 1. And we end up squaring that, so there's actually two of them. So we can take 5x squared plus 20x plus 6. We can divide it by x times x plus 1 squared. And according to our rules here, for if we only have one factor, meaning px plus q to the 1, we're just going to have this single term there. And that's what happened before to us. And then for the x plus 1 squared, we're going to have these two. Okay, so this thing is going to become now a over x and that's belonging to the x. And then for the second one, we can use any constant we want. Remember, we have to solve for them. So I'm going to use a, b, and c. Plus b over x plus 1 plus c over x plus 1 squared. Now, if that was an x plus 1 cubed, we would have another one right here that would go up to the cube. But it's not. So I'll get rid of that. Okay, so we need to figure out a way that we can solve for a, b, and c. And to do that, we're going to, again, multiply by the least common denominator and see what happens. So in this case, the least common denominator is x times x plus 1 squared, the one that we're trying to turn this into. So let's multiply both sides by the least common denominator, x times x plus 1 squared times the left-hand side, and then also times the right-hand side. All right, so we're going to have to, we can cancel on the left. On the right, we have to distribute to each of those three terms. So what we end up with here would be 5x squared plus 20x plus 6 is equal to, and then when we distribute on the right, we're going to have a times x plus 1 squared divided by x plus b x times x plus 1 squared over x plus 1, and then the same for c. All right, so we get a lot of cancellations here. On the left it canceled. Here the x's are going to cancel. On the next one, x plus 1 is going to cancel, but just one of them. And then on the last one, the x plus 1 squared is going to cancel. So we have 5x squared plus 20x plus 6 is equal to a times x plus 1 squared plus b times x plus 1 plus c times x. And now we're going to do a little bit of terrible algebra. We have to distribute all of this and kind of expand it. So this is a times x squared plus 2x plus 1 plus bx squared plus bx plus cx. So that would be ax squared plus 2ax plus a plus bx squared plus bx plus cx. Okay, so I'm going to combine all the x squared terms. So we really have an a plus b that's attached. Those are both attached to x squared. What's attached to x? We have a 2a and a b and also a c. And then what's left over with no x, I think just that a here. So now what we're going to do is rewrite the left-hand side, 5x squared plus 20x plus 6. And if we look at this, we can actually compare what's attached to the x squared. Well, it's got to be 5, which for us is just a plus b. What's attached to x? A 20. And on over here we have a 2a plus b plus c. And then what's left over is just the constant, the 6. And on the right-hand side, it's just the a. So we know now that 5 is going to be equal to a plus b. We also know that 20 is equal to 2a plus b plus c. And then lastly, we know that 6 is equal to a. So if 6 is equal to a, that means that 5 is equal to 6 plus b. Well, that means that negative 1 is b. So far we have 6 as a. We have negative 1 is b. And now we just need c. So 20 is equal to 2 times a plus b plus c. So that's really 12 minus 1. That would give us 11 plus c is equal to 20. And that means that c must be 9. All right. So what this means is the integral of 5x squared plus 20x plus 6 divided by x times x plus 1 squared dx is really the same thing after our partial fraction decomposition as the integral of a over x, which was 6 over x, negative 1 for b, so minus 1 over x plus 1, and then 9 as c, so 9 over x plus 1 squared. dx. All right, so this is the integral of 6 over x dx, and we know that that would just be the natural log of x. So 6 times the natural log of x minus, well, we just have x plus 1 on the bottom. That's going to be another natural log. Natural log of x plus 1. If we did a u substitution, it would just be du is dx. This is where we might want to do a u substitution, but we see that it turns out to also have du equals dx. So if we have the integral of 9 over x plus 1 squared dx, we would let u equal x plus 1. So du would just be dx. So it's really the integral of 9 over u squared. And instead of dx, we have du. So that's really 9 u to the negative 2 du. So if we integrate, we get u to the negative 1 divided by negative 1. We know plus c, so that would just become negative 9 over whatever u is, which is x plus 1. So let's put that in there. Negative 9 over x plus 1. And then we have plus a constant. All right, and the third case is if our denominator d of x is of the form of a quadratic. So ax squared plus bx plus c, but we could raise it to the nth power. And if that is the case, then the decomposition is going to be, so instead of just an a on top, we would actually have b1x plus c1 over the polynomial. And we would have that up to the degree. So next we would have b2x plus c2 over ax squared plus bx plus c to the second power. So just like the last one, if it's quadratic, instead of just the a on top, we have bx plus c, and it's going to have the same thing where it goes up to the degree. So bnx plus cn over ax squared plus bx plus c to the nth power. All right, so we'll do an example of this now. 2x squared minus x plus 4 divided by x cubed plus 4x dx. So again, the first thing we do is we focus on the denominator. So x cubed plus 4x, we can factor out an x, and then we'd have x squared plus 4. And remember that x squared plus 4 is not factorable. So we can write this thing as 2x squared minus x plus 4 divided by x times x plus 4, x squared plus 4, which is going to be a over x plus, and now we would have bx plus c, since that's quadratic, over x squared plus 4. And a quick note, if the denominator was x times x squared plus 4 squared, it wouldn't stop there. Then we would actually have this plus dx plus e over x squared plus 4 squared. We'd have that extra term on there. All right, so let's multiply both sides by the LCD. And when we do that, we're going to have 2x squared minus x plus 4 is equal to a times x squared plus 4 plus bx plus c times just x. So that would give us ax squared plus 4a plus bx squared plus cx. So if we group everything again, we're going to have a plus b attached to x squared. And what else do we have? Now we have cx plus 4a. So this would be a good time for you to try to do what we did last time and solve for these a, b, c constants. And remember, we just want to compare, since we got it in the correct form. What's attached to the x squared? Well, 2. But on this side, it's really a plus b, so that means that a plus b has to be 2, and so on. So if we solve for these, we know that a plus b is equal to 2. We know that c is equal to -1, and 4a is equal to 4. So c is -1. That's good. A must be +1. And what does that mean for